Hi everyone, I am Thariq Hussain, a cybersecurity researcher and someone who is still growing and building my skills in this field. Right now, I am exploring one of the most powerful tools used in cybersecurity and SOC operations, Wireshark. Wireshark is an open source network analyzer that lets us capture and inspect network traffic in real time. It's widely used by cybersecurity researchers, SOC analysts, penetration testers, and network engineers. So in this video, I am going to walk through the basics of Wireshark. We will look at the interface, understand the different panels, explore menus and preferences, capture some packets, and analyze them step by step. This is part of my learning journey, so there might be some small mistakes, but I hope it helpful anyone who learning along with me. Alright, let's get started with Wireshark. Now we are inside the Kali Linux. So I am using the Wireshark in Kali Linux, which is to inside the virtual box. So the good thing about the Wireshark is it is supported by almost all major operating system, whether it is Linux, Mac, Windows, or any other Chrome OS like any steps. So in Kali, the Wireshark is pre-installed, so we don't need any manual configuration or setups. So we just open the terminal and type Wireshark and just click enter. That's it. Okay, so this is the introductory screen of Wireshark. And as soon as I open the Wireshark, you can see the welcome window here. And at the top, there is some tools or menus. So these are the menu bar, which consists of some menus like file, edit, view, code, capture, analyze, etc. So these menus contain all the tools we need for analyzing network packets, applying filters, and performing different types of inspection. So just below this menu bar, there is also a toolbar which consists of some quick access buttons such as start, stop, capture, opening the captured file, saving the captured file, inspecting the packets, and other many set tools. So these are all about the quick overview for menu as well as the toolbars. So just below the toolbar, there is an open area which consists of previously saved PCAP or PCAP-NG extension files. So you can see I already have a file named card protocol analysis.pcap pcap-ng. So this is downloaded in my download folder inside my caddy, and we can analyze it in the later stages. So below that, there is a capture area, which consists of available network interfaces, whether it is EGH0, the net 0, any LO for loopback, and other artificial, virtual interface like NFQ, debug system, debug session, and so on and so on. And right next to each interface, there is a small long box, which is used for capture filter. These capture filter allow us to limit which packet Wireshark collect during the live capture. For example, capturing only HTTP traffic or capturing only TCP traffic. So I will explain more about capture filter along with display filter in the next section. So it will be more easier to understand both together in detail. So that's a quick overview of the Wireshark opening screen and how it's structured. Now let's move on to one of the most important topic in Wireshark, the capture filter as well as the display filter. These two might look similar because both involve filtering packets, but they actually serve two completely different purposes. So let's go through them one by one. First of all, we have to go through with capture filter. Capture filter is used before Wireshark start recording packets. In simple words, it tells Wireshark what kind of traffic to capture and ignore the rest. This is especially helpful when you only want to capture specific types of data instead of recording everything happening on the network. So for example, let's say I only want to capture packet related to HTTP traffic. So, so before I start capturing, I can go to the capture filter and I can simply type TCP space port space 80. So the port 80 is a default port for HTTP and we can press enter. So when I open the browser, we can see the packets are visible. So these are the typical HTTP TCP packets, and all other traffic like DNS, HTTPS will be ignored. Okay, so this way we can filter out the packets using capture filter. So similarly, if I want to capture packets only from a specific devices, I can use something like let's say something like host space that specific IP address of the device 192.168.98.67 whatever it is, and we can press enter. So now we can capture the packets from that specific devices, that specific IP, and in other case, so in other case, let's say if you want only if you want to capture the ping request or ping packets, then you can simply type ICMP and press enter. So that you can capture here the ICMP packets. So this way we can capture the packets from capture filter. And the main idea here is capture filter only capture filter controls what enters the capture process. Once you have started recording, you can't change or apply capture filter. So you have to set it before you hit the start button. So these all are about the capture filter. Now let's move to display filter, which work a little differently. The display filter is applied after the packets are captured. It doesn't affect what was collected. Instead, it helps you focus on what you want to see from the existing packet list. So for example, suppose I didn't set any capture filter earlier and I have captured everything. So I'm going to start button. So here the packets will be visible as soon. Then you can so that okay, the packets are coming. These are a bunch of packets with TCP, DNS, HTTP. These all packets are mixed. Different protocols are mixed here. So now I want to view only HTTP traffic from the large capture file. In that case, I can simply type HTTP and press enter. So now there is no HTTP packets. So I am going to type I want to capture HTTPS packet. So here I am going to type TCP dot port equal 443. So these port 443 belongs to HTTPS. So these are the HTTPS packets listed here. Okay. And if I want to check communication with a particular IP address, I can use display filter like IP dot ADDR, and we can choose from these, can choose from any IP address. And if I only want to see DNS query, I can simply type DNS and press enter. So this is the way we can use the display filter from the bunch of mixed protocol packets. Okay. So in short, capture filter decide what to capture, while display filter decide what to show from what's already captured. So you can think it of like the capture filter works like a gatekeeper, and it decides what comes in, And the display filter is more like a search engine. It helps you quickly find what you need after everything is inside. Okay, so practically you will often use both capture filter as well as the display filter. When you if you use the capture filter when you want to limit traffic during live capture, and display filter when you are analyzing the data later. Okay, so that's how both filters work in Wireshark, and using them properly can save a lot of time and make your analysis much more efficient. Now let's play with something really useful, a logical operator in Wireshark. These let us combine conditions and make our filtering a lot smarter. So I will show you live how they work with some simple example. Okay, first let us try the AND operator. Okay, think of AND like this. I want a package that match this and this conditions together. So I will show you up with some example. Since you want to capture from a specific IP and want to capture from that specific protocol from that specific IP, then you can run the command IP dot src equal that specific IP. If it is 142 dot 250 dot 205 268. I am using this IP because I am capture some packet from this IP, and if I want the TCP protocol TCP, then I can click enter. So you can filter out the TCP packets from the source IP that I mentioned, 142.250.205.68. So this way we can filter out the two conditions. Okay, so this is about the AND operator, and if we move to the OR operator, let us try with some example. Let's see, either I need HTTP or HTTPS traffic. So I can use the command tcp dot port equal 80 or tcp dot port equal 443. That is for HTTP and HTTPS. When I click enter, you can see the protocol from 443, and you may or may not be seeing the protocol from 80 because we are using the OR operator. So either 443 or 80. So you can completely see here 443 from and go from this protocol. Okay, so this is all about the OR operator. Now you can use another type of operator called NOT, and honestly this is super helpful. It's basically telling Wireshark I don't want to see a specific IP or specific protocol. For example, look, here is full of TCP based protocol. So if I don't want that particular TCP packets, I can simply type NOT TCP and then click enter. So you cannot see any TCP packets here. So it will be more helpful that if we can ignore any packets simply like that. Okay, and if we do not want this quick packets, then you can write QUIC not Q, then you can't see such packets here anymore. Okay, so this is all about NOT filtering or NOT operator. Now we can move to XOR operator. Now XOR is not something we use every day, but it's still good to know. XOR means show me one or the other, but not both at the same time. Okay, so we can try the basic protocols. TCP.port equal 80 XOR TCP.port equal 443. So if you are trying this, it shows a packet going to port 443 or 80, but not both conditions together. So this is all about XOR. And if you want to know more about this filtering or such operator, you can go through the Wireshark cheat sheet from Xstation. It contains all the commands, filters, and syntax. It contains logical operators. How we can use the filters? What filters we can apply for getting what result? So this is the common filtering command we use in our daily life as a SOC analyst, and you can check out this website for more information. Alright, since we already talked about the menu bar, the toolbar, the display filter, now let's move on to how Wireshark actually arranges everything on the screen. So the first thing is layout. The layout decide how the main parts of Wireshark are positioned. So Wireshark mainly has three sets of panel that and layout controls how these trees are arranged. So the first one is the packet list, whether which is I am showing in the arrow mark. It is the packet list panel. This is the top section where you see all the packets in order. Every row represent one packet. That the single row represents a single packet, and this is where you will spend most of your time scanning what's happening. Okay, so this is all about packet listing. And the second panel is called packet detailing. And this is what can I say? Whenever you click a packet, so when you click a packet, it's breakdown layer by layer. So the information regarding a single packet will shown here, and it is breaks into layer by layer, whether it is Ethernet, IP, TCP, or UDP, and then application protocol like HTTP or DNS. And this is where you understand what exactly inside the packet. Okay, so this is all about the packet details. And the third one is hex view or the packet bytes. So this shows the raw data of the packet in hexadecimal or in ASCII characters. So while packet details are nicely decoded and easily to read, the packet bytes shows the real raw data that was captured on the wire. Okay, so this is all about the layout section. So here we can customize these three panels according to our preferences. Whether you are a SOC analyst or network engineer or malware analyst, whatever the role is, you can customize these three section according to your preferences. For doing that, you have to go to edit menu and go to preference at the bottom, and in the appearance tab you can see a layout section, and layout section you can have different option to arrange these panels. So if you prefer the first one and set up play, you can see the three things: the packet listing, packet detailing, or the packet bytes are arranged in this order. You can change into any other model like this, or like this. Here it is arranged in side by side, and here it is arranged in vertical format. Vertical format. And also you can make changes by ignoring any one of these. If you don't want packet list, then click the option none and click apply. Then you can list only the packet detailing on packet bytes. The packet list will be disappeared. And if you need only packet list, then click the sections none on both of these and click apply. Then you can only visible packet list. So this way you can arrange the layout. Okay, so I am setting it to default packet detail and packet byte, and click apply. Okay, so the next thing is the font and color. So if you notice that when we type here, when we type in display filter any invalid command, you can see the red color here. These red color will appear in the display filter. And if you type any valid command, then you can see the green color. This all depends upon the font and color we set defaultly. So default, the valid color is green and the invalid color is red. So you can change this according to your preferences. If you want any white color, if you want white color for the valid command, then you can set white. And if you want green color for invalid command, then you can set it like that and click apply. So if you type HTTP, it's an invalid command in display filter. Sorry, HTTPS. When you type HTTPS, so it shows a green line. That means it's an invalid command. And if you type IP dot address or whatever, it's a valid command, then you can see here the white color. It's all depend upon your customization or your preferences. Okay, so this is all about the font, sorry, the color. And when you looking for the font option, there is different types of option. If you set anything, you can see like that, you can see according to that font. Okay, so it's a simple thing. You can change according to your preferences. So I am changing it to default stage. Green is for the valid and red is for the invalid. Okay, so this is all about font and color. Now let's move to column. So column decides what information you want to see in the packet list, like number, time, source, destination, protocol, length, and info. So these are detailing of the specific packets. So Wireshark let you fully customize this. So you can remove any column if you don't need, or you can add new one based on your analysis, or rearrange them to fit your workflow. That is totally up to you. So for example, if you need in preference, go to the column section. So here you can see the checklist. Here, if you don't need the length, if you don't need the length, then just uncheck that and click apply. Then you can see here that it will be visible. It will be invisible now. So you can check the apply so that the length detailing has to be gone here. So this is the way you can customize the column. And if you need an extra option, then click the plus mark and add. If you suppose if you need any destination port here, if you need a destination port, then type the name destination port and give the type as destination port. Here you can here you can see destination port, and then click apply. Then here you can see the destination port. So this is the way you can add or delete any columns. Okay, so this is the way you can customize the column. And next one is the coloring rules. So if you go to view, then there is a coloring rule. So this is the default coloring rule set in the Wireshark. So for TCP you can see, and this color at a white shade, and UDP you can see this light blue color. And if if you want to change this UDP color, then select the packets and go to the background section, and if you want a yellow color for UDP, then click select. So now if UDP packets are capturing, you can see the yellow color here. So this way you can change the rule. And if you can add any a new rule here by selecting the plus icon. You can add the new rule here. So this is the way you can change the coloring rules. Okay. And another important thing you have to remember about Wireshark is the profile section. Whenever you customize something inside a profile like your layout, columns, coloring rules, or fonts, which I have demonstrated earlier, all those changes are saved inside this profile section. So if I'm currently using, in my case, I'm currently using the default profile section. So if I am switching to any other profile, such if I am choosing the SOC profile, at that moment, everything changes back to the settings of that new profile. It doesn't carry over what I customized earlier. It basically loads the new profile's default environment. So you might feel like everything suddenly went back to a different setup. But that's because each profile maintains its own independent settings. So in short, any changes you make apply only to the active profile. When you switch profile, the Wireshark doesn't delete your settings. It's just load the setup of the profile. If you go back to the previous profile, all your customizations will be there. So this is why profiles are so useful. Each one keeps its own layout, its own column. And you can also add new profile by right click and just add the new, or in the manage profile you can have an plus icon if you can choose and add a different profile according to your project or your work. Okay, so this is all about the profile. Okay, so now in this part of the session, we are going to actually perform packet analysis using HTTP traffic. The idea is to generate a real login request, capture it with Wireshark, and then analyze how the data look inside a packet. So this will help us to understand why HTTP is insecure and how easily the information can be viewed inside the capture. Okay. So since I already know I am targeting HTTP traffic, I will start by applying the capture filter here. Uh, we all know that capture filter are used before the capture begins. So they allow Wireshark to record only the specific traffic we care about. Okay. So first of all, we select the interface and just type TCP port 80. So default port for HTTP and click enter. So here which will capture only the HTTP packets. So now next time open a deliberate vulnerable website from Acunetics, so that I'm opening the Firefox and type the command vulnerable web by Acunetics, or we can type test.php. This is the site. So here I am trying to log in with the default username or password set in this website for a testing purpose. Actually, this site is purposefully designed for training and demonstration like this. I will fill in the sample username and password with the sample, and I'm trying to write username as test and password as test, and now I click login. Yes, is always open. So now I minimize it and now I stop the capturing. So now the HTTP request has been captured here, and so we can now analyze the packet row by row. And when I'm inspecting the packet, so I can see here there is a post request, HTTP post request, and when I select the packet, I can see the detailing here and also the packet by row packet bytes here. And if I want to analyze this packet detailing, you can right click the packet and go to the follow, then HTTP stream. So in this window shows the entire client and server conversation, and the Wireshark automatically colors the text to make it easier to read. So everything in the red is sent from the client to server, that is from the client side, and everything in the blue is sent from the server back to the client, that is from the server response or server side. So after, we can try to notice whether the credential, that username or password I typed in the website, will be shown here or not. So it is there, it will show in a plain text. Okay, so right here, in red, you can see the exact username and password I just typed. So it's completely visible because it is an HTTP protocol, and HTTP sends the package in plain text. There is no encryption at all. So the data appears exactly as it was typed into the form. So this is demonstration. So these demonstrations show how exposed HTTP communication is. On a public or insecure network, anyone who intercepts the traffic can read these details the same way we are seeing them now. And this is exactly why we always recommend using HTTPS over HTTP. HTTPS encrypt the entire communication because it use certain certificate like TLS or SSL certificate. Since the communication is encrypted, so no one can able to read the username, password, sensitive informations, or any cookie details like that. So this is all about HTTP packet analysis demo. Now in this part, I am going to show you how a port scan looks from the defender side using Wireshark. Okay, so everything is done inside my own virtual lab, my attacker machine, and this is my attacker machine and this is my victim machine are both mine. This is just for learning and SOC analysis. Okay, so before I start scanning, just look at my Wireshark window. It's so clean and peaceful right now. A few ARP packets, some DNS, ICMB, and some UDP packets are here. It's normal and calm. This is exactly how a normal system looks when nothing suspicious is going on. Okay. Now I am going to pause here and move to my attacker machine. So this is the attacker VM again, and all it's all inside my lab. Now I am going to run an nmap scan from here, a full port scan. Okay, so I am typing the command. So before I am typing the command, I want to know the victim IP, so that I'm opening terminal. So you can see the IP here, 192.168.10.43. Okay, so I want to scan this particular IP, nmap -A for aggressive scan and -P- for the full port scan and that particular IP. Okay, so the time when I click enter, you have to visualize it in the Wireshark. Okay, so now I'm trying to click enter. So here, so in the Wireshark window, you can see the moment I switch back, Wireshark suddenly exploded with packets. Just a few seconds ago, it's looked nice and clean. Now it's like a firework on the screen. Okay, now I am minimize the attacker machine and try to open it in a full. Try to open in a full window. Okay, here you can see the SYN packets going from a particular IP to a destination. Here the SYN packets coming is continuously from the same IP. The source IP stays the same, but the destination port keep changing every time as you looking at. When I'm switching from one packet to another, you can see here the source port and source IP remains the same, but destination port, you can look here, the destination ports keep changing. Destination ports are keep changing one by one. It means that scanning the entire port, it's scanning the entire port. That's a big sign something is scanning us. So if you want to show it clearly, I can filter out this with the SYN packet TCP dot flags dot SYN. Okay, now it's crystal clear. The device is sending non-stop SYN packets. That's SYN to port 80, SYN to port 443, SYN to 1622, whatever the port number is. It's literally walking through the entire port range. This is exactly the textbook port scanning behavior. So for the visual evidence, you have to go through the statistics and just open the IO graph. You can see here, before there is a normal packet drained. Now after this flood happened, the packets goes up to 100 packets per second. So look at this spike, this sudden boom, huge burst of packet per second. This is exactly what automated scan look like on a graph. And when you look about the conversations in IPv4, you can see there is a list of IP address where the conversation has take place, where we have a suspicious IP, that 192.168.46 here. You can see the packets sent by this particular IP is far more than what the others send. It's almost 15,702 or somewhat like that. So here the conversation, you can clearly see one IP taking thousands of different destination ports. This absolutely confirms the IP is the one scanning the system. You can also look for the endpoint detection. In endpoints IPv4, you can see that particular IP here. You can see here the amount of packets sent by is almost 18,000. There we go, the same IP showing the highest number of packets. So this is definitely our scanning host.